answer that you will see in the solutions that I'm going to post. But who cares? We are only interested in practicing as much as we can. So 26. So this is problem 7. Yes. So 26.39 and correspondingly 5.41, 12.97 and 30.55. 19.69, 31.64, and just one more, 13.23 and 79.57. So in StatCrunch, I want a new data table. So I have two variables now, x and y, so let's enter them correctly. So 26.39 and 12.97 and 19.69, and last one 13.23. 5.41, 30.55, 31.64, and the last one 79.57. So we want to graph a scatter plot with the x and y. So this is the scatter plot. And of course, I cannot draw a conclusion with 4 points, obviously, about the entire population. There is no way. But we're just trying to practice this. So the first question was asking us to find the predicted. So then I need to determine, first of all, whether determine the coefficient of correlation. Then look in the table and see if it's with 4 data entries, 4 ordered pairs, if that is a valid conclusion. So for now, so go to regression, simple linear, and I want x, and I want y, and I don't want any of this, but I want to predict, and they're asking us to predict for 15 and then 25. So I think it allows us to put a comma, I think, and 25. Let's see. To predict. Okay. So the correlation coefficient is R equals negative 0.7523. Then the prediction is right here, the predicted values. So variable 2, which is y hat, equals negative 3.6663 x plus 103.0423. And the predicted value for 15, here it is. So when x equals 15, the predicted value of y hat is 48.047, or 80 actually. And for x equals 25, the predicted value is 11.3851. So now we have to look at this table in case we're asked to do that. So I only have a sample size of n equals 4 ordered pairs. So for 4, the correlation coefficient should be, in order to assume that this is a linear relationship between the two variables, should be positive or negative, but more than, in absolute value, more than 0.95. It's not. So I would have to conclude that just for these 4, the linear regression model is not applicable, because I only have 4. Now see, the table stops at 30, right? So if you have 100, whatever you get is most probably acceptable. But if it's a number between 3 and 30, and if it's not at least an absolute value, at least a number corresponding to the number of data set, to the sample size, at least this, and these are the critical values, minimum this, then you will have to conclude that the relationship is not linear. And that was it with this problem for 15 and 25, and that's it. So they're asking us to write percent, so good. Let's move on and see what else. Sasha, did you find your questions from chapter 4, or I continue with something else?
Continue. I'm good if you want to continue.
Okay, so I'm looking now at these problems, starting with 18. I would like to look at this one, 19. So let's look at 19. Determine whether the distribution is a discrete probability distribution. Okay, so we know how to determine that, so that's not the big deal. But what I would like to ask here is to find the mean. So for number 19, this is not what we are asked to do. Here in this problem, we are only asked to do, say, yay or nay. But if it is a probability distribution, I would like to determine the mean and the standard deviation. Can anyone tell us whether it is or it is not? Or we can look at, if that's what we want, because this one is definitely a probability distribution, we can look at 20. And then I would like to look at some binomial probabilities.
We still looking at 19?
Yes, if it's a probability distribution. If it is,
scroll back up.
Yes. Yes, you have it too. It's posted.
Right, but I'm looking.
Oh, sure. Yeah. Of course.
It is. What did you see?
It adds up to 1?
Yes, it does.
Okay, so it is a probability distribution. So we either use this or we use this to answer these questions. In other words, to find the mean and the standard deviation. This is the same. I'm adding these two questions here. So let's copy that. So we have 0. Oh, this is not good. So we have for x 0, 1, 2, 3, and 4. And the probability is 0.16, 0.17, 0.35, 0.24, and 0.08. So this is the one with that we had to discover. Oh, I didn't mean that. Okay. This is the custom one. This is the custom one. So please enter 0, 1, 2, 3, 4. And then the probabilities, 0.16, 0.17, 0.35, 24, and 0.08. I did not check, but I trust you fully that you checked and this is okay. So, let me go back. Where do we find where is my custom? Okay, right here, it's hidden. Oh no, it's not. Where is my custom? I think I have to go to calculators first. Yeah, okay. So calculators and then custom. And x is x and the weights or the relative frequency is 2. Okay. So now it knows that we're talking about a population. Okay. So here it is. The mean, 1.91, and the standard deviation, 1.1670. Any questions on this? How do we interpret this if we need to? Where is my book? Not my book. Okay. So how do I interpret this? How do I interpret the mean or the expected value?
Isn't it like after a number of experiments, like it?
As the number of experiments increases, yes,
Right.
the mean, yes, will approach the mean of the random variable. Exactly, that's what it is. Very good, awesome. Okay, I would like to look at binomial experiments. So let's jump to 23 and we'll come back. Okay, here's a binomial experiment. Problem 23. So we have n equals 10, p equals 0.25, and we want the probability for x less than or equal to 4. So remember how are we thinking about the probability of a binomial experiment or binomial random variable? So we're talking about n equals 10. So from 0, 1, 2, ... 10. Less than or equal to 4 will be this. 4 included. 5 and more? No. Yes. Less than or equal to. So I have the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. In case you are using a calculator, it just disappeared on me right here. Then you will have to use second and distributions and scroll up to Binomial Cdf. Cdf. With, let me write it here, Binomial Cdf with npx, n being 10, p being 0.25, and x in this case is this, 4. So, and you will add, you will accumulate all of them. So the trials is 10, probability 0.25, and then 4. And when I press enter, I get 0.9219. Now, with StatCrunch, I want binomial. I want binomial, but not this one.
It's that calculator.
Calculators, yes, it's always hidden in there, yeah.
It's the second one.
It's the second one, thank you so much. So we want 10. I want less than or equal to 5. Oops, less than or equal to 4. And the probability 0.25. And we have to get the exact same answer. It has to be 0.9219. Good, let's go back. According to an airline, let's look at problem 24. According to an airline, flights on a certain route are on time 90% of the time. So I'll stop for a second and take notes. So this is my first note. And this, I'm on page 6, I think, yes. So this is 24. So probability of success, 0.9. Immediately, Q is 1 minus that, which is 0.1. So success, 0.9, failure, 0.1. Suppose N equals 8 flights. N equals 8. A random is selected and the number of on-time flights is recorded. So there are only 2 outcomes, right? On time or not. Success, 0.9, failure, 0.1. Determine whether this is a binomial experiment. Okay, so let's think about it. So there are four different conditions. This is fixed. Obviously, this one is fixed too. I do have a fixed number of trials, and they have to be independent. and the number of trials is fixed. So all these conditions are fulfilled. So I would say yes, this is a binomial distribution. Find and interpret the probability that exactly 6 flights are on time. So P that x equals 6. The next one, that at least greater than or equal to 6 are on time. Fewer, not equal to, fewer than 6. And finally, the probability that between 5 and 7 inclusive. 5 and 7. Okay, so let's take a look. So probability that exactly 6. Probability that at least 6. I have in my pocket at least $6. Fewer than, not equal to. This is exactly the same with the probability for x to be less than or equal to 5. These are the same. And here in between. So let's go directly to StatCrunch, since we have it ready here. Okay. Second one up here. Okay, I should have not closed it up. Okay, so n, we have 8. We don't want in between, but I want the standard, right? So less than, I want equal to. First, I want 6, and the probability 0.9. So I get 0.1488. Greater than or equal to 6. As you see, that probability is 0.9619. Less than 6. The probability is 0.03809. So now if I put less than or equal to 5, the probability has to be identical with what we just got a second ago, 0.03809, blah, blah, blah. And now for between, I have to use the, and click the between, and I have between 5 and 7, and compute. And that is 0.5645. Any questions?
Were you doing that on StatCrunch?
Okay, let's start from the beginning.
I was doing it on my calculator and I